Hi, my name is Sean Simpson, and you are watching my video lab report on Lab 5, focusing on first order sensors. First off, I'll show you my circuit. Red is the input and black is the ground, as usual. The analog outputs are green and orange, green resulting in the input voltage and orange resulting in the voltage across the capacitor. Now we'll move on to my MATLAB code. For the MATLAB code, after I run it, you're able to see that since the 10 kilo ohm resistor has a very low time constant of 1 millisecond, it is able to charge up the capacitor much faster than the 100 kilo ohm resistor. And that has a 10 millisecond time constant. Now we are able to move on to my Arduino code. For this code, I just initialized all constants at first and then set all the pin modes as well as adjusted the baud rate. I then created analog read for every pin and set the digital write for the pin in to be low for 5 seconds in order to take all the voltage out of the capacitor. Now, when I went into the loop, I created a float constant called tau, which is the time constant, which is equal to the resistance times the capacitance. And then I set the voltage, the input voltage, as high for 10 time constants, and every time constant divided by 50, I had it measuring the voltage, and then using a for loop. And then after that, the voltage in switched to low, and it continued measuring it every 50 time constants, or every 50th of a time constant. Now moving on to processing. For adjusting the processing, I implemented a for loop to create lines on the grid, and as well as voltage values for the lines. And down here, I created a legend by using simple text and creating ellipses. And when I run it, you're able to see that it's working after 5 seconds, of course. Now in this, the Vin is a step function, so it's moving up and down at a split second time, and the Vout is then discharging or charging depending on the Vin. And depending on what resistor, currently I have a 10 ohm resistor on there. The time constant matches up to be 1 millisecond as well on these graphs. Now, moving on to the final part of the MATLAB code, which is the trickiest one. I had a little bit of trouble here and I was not able to finish because the CSV function, or the CSV read function, was not implementing, or it wasn't reading any of my files. I first tried by accessing just a regular data CSV file like I put in the processing to save as. That did not work. I then went specifically and tried to use a specific time. That did not work as well. And then I tried the third option to do a users and create a pathway for it to access the data, and that also did not work. But I understood that to change the values, I would have to divide by 512 the bits and then multiply it by the voltage. And that's implemented in the Vin and the Vout, as well as down here, I had to change the Y label for volts. And that's all. Thank you for tuning in.